12 types of holes in engineering drawing and manufacturing. Holes are critical features in engineering drawing and manufacturing. Their functions can vary depending on the type, including assembly fastening, channel or passage for fluid flow, positioning, weight reduction, etc. In this video, we'll introduce 12 different types of holes and their uses. Let's start with the most basic hole type, the simple hole. It's just a basic circular hole drilled into a material without any additional features. While simple, it serves as the foundation for more advanced hole types. On engineering drawings, it's typically represented by a diameter symbol, phi, followed by the hole size. But what if a hole needs to pass completely through the material? That brings us to the through hole. It allows screws, bolts, or other components to go from one side to the other. This hole is also marked with the diameter symbol, phi, sometimes with a depth specification if necessary. If there is no need to go through, this is the blind hole. A blind hole stops at a specific depth, keeping the opposite surface intact. These are useful when you need a secure space for fasteners without puncturing the entire material. On technical drawings, blind holes often include depth symbols to indicate how far they go. Next, countersink hole. It's designed for flat head screws, allowing them to sit flush with the surface. You'll often see this hole with an angled dimension marked on engineering drawings. It is typically C-sink 82 degrees or C-sink 90 degrees. Its callout is V. Countersinking is widely used in aerospace and automotive applications. Speaking of fasteners, let's talk about the threaded hole. Instead of relying on nuts, this hole has internal threads, allowing screws or bolts to fit directly into the material. It's commonly marked with thread specifications, such as M8 by 1.25, where M represents metric threads, 8 is the diameter, and 1.25 is the pitch. Next, tapping hole. Both tapping holes and thread holes are used to create internal threads, but the key difference lies in the process. A tapping hole refers to a hole drilled in the material to prepare it for tapping, where a tap tool is used to cut internal threads. This hole is typically smaller than a standard thread hole because the tapping process will enlarge the hole as it cuts the threads. So a tapping hole is essentially a pre-drilled hole. If you want the bottom of the hole to have a conical shape, then you'll need tapered hole. It is a conical-shaped hole that gradually narrows from the opening to the base. Unlike a straight hole, which maintains a uniform diameter, a tapered hole has a consistent angle of inclination along its depth, creating a sloped profile. Tapered hole is often used to securely fit tapered pins, shafts, or tools, as the taper creates a tight, self-locking fit due to the wedging action when the component is inserted. Counterbored hole. It is like a countersink, but instead of a cone-shaped recess, it has a flat-bottomed cavity. This allows socket head screws or bolts to sit flush, which not only protect the fasteners, but also enhance the aesthetic beauty. Its callout is counterbore symbol, along with the diameter symbol and N value. For example, counterbore symbol with diameter 20 refers to a counterbore with a 20 millimeter diameter. Next up, the reamed hole. This is one that's been precisely machined for accuracy. After drilling, a reamer tool smooths and expands it to a precise diameter, ensuring tight tolerances. These are used in applications where high precision is required, like bearing seats. But what if you need a hole with an exact depth and no taper? Here you'll need flat-bottomed hole. Unlike standard drilled holes, which naturally form a slight taper at the tip, this hole remains completely flat. Overlapping hole. It refers to partial or full intersections of two simple holes, typically used in metal forming applications. Although overlapping can decrease the material strength, reinforcing can counter this. Moreover, these are found in complex assemblies and custom metal fabrication. Finally, clearance hole. It's slightly larger than the screw or bolt passing through it. This will prevent friction and allow free movement. Clearance holes are crucial in assembly processes where parts need to align smoothly without binding. We've looked at 12 different types of holes. Now let's go deeper into the hole tolerance. Hole tolerance is the allowable variation in the hole's size to ensure the right balance between fit and function. If a hole is too small, parts may not assemble properly or require excessive force. If it's too large, the connection may be weak or unstable. There are 3 common fits used in hole tolerance. 1. Clearance fit. In this case, the hole is always slightly larger than the shaft or fastener, allowing easy movement. You'll see this in rotating parts like pulleys or in assembly processes. 2. Transition fit. This fit is right in the middle, not too tight, not too loose. It allows for some resistance during assembly, but still enables parts to come apart if necessary. It's commonly used in applications like bearing housings, shafts, or parts that need to slide with minimal play while staying securely in place during operation. 3. Interference fit, also called a press fit. Here, the hole is actually smaller than the part being inserted. This creates a super secure friction-based connection. You'll find this in applications like gears, bearings, and structural components where movement must be prevented. Now, how do you decide which tolerance to use? It depends on 3 key factors. 1. Application. Does the part need to move freely, fit snugly, or be permanently locked in place? Your choice of fit should match the function. 2. Hole size and geometry. The larger the hole, the greater the potential for variation. Also, complex shapes or deep holes may require tighter tolerances to maintain accuracy. 3. Work material. Different materials expand and contract at different rates, so tolerances must be adjusted based on thermal and mechanical properties. Want to learn more about different types of holes? Feel free to leave a comment. Besides, don't forget to like, subscribe, and share it with fellow engineers.